The crews of MiG-31 interceptor fighters and Su-24 bombers from the Composite Air Regiment of the Northern Fleet's Air Force and Air Defense Army performed training flights in adverse weather conditions. The press office of the Western Military District reported on Friday. The training flights became the most massive exercise this new year. As many as 10 aircraft simultaneously performed combat training tasks in the sky. Over the flight shift, more than 40 sorties were made and more than 20 crews of the Air Regiment practiced their skills, the press office said in a statement. The pilots of fighter jets and bombers were sharpening the skills of takeoffs and landing in a snowfall, low clouds and poor visibility during the day and the polar night. The crews of Su-24 planes practiced heading for an attack and notional bombing. The pilots of MiG-31 aircraft practiced tactical measures upon intercepting an air target and conducting a dogfight and also performing aerobatic maneuvers, the statement says. The Mikoyan MiG-31 is a supersonic interceptor aircraft developed for use by the Soviet Air Forces. The aircraft was designed by the Mikoyan Design Bureau as a replacement for the earlier MiG-25 Foxbat. The MiG-31 is based on and shares design elements with the MiG-25. The MiG-31 has the distinction of being one of the fastest combat jets in the world. It continues to be operated by the Russian Air Force and the Kazakhstan Air Force following the end of the Cold War and the collapse of the Soviet Union in 1991. The Russian Defense Ministry expects the MiG-31 to remain in service until 2030 or beyond. Serial production of the MiG-31 began in 1979. The MiG-31 is able to maintain combat effectiveness despite the potential use of active and passive radar jammers and thermal decoys by adversaries. A group of 4 MiG-31 interceptors is able to control an area of airspace across a total length of 800 to 900 kilometers, 500 to 560 miles. Its radar possessing a maximum detection range of 200 kilometers, 120 miles in distance radius, and the typical width of detection along the front of 225 kilometers, 140 miles. MiG-31 production ended in 1994. The first production batch of 519 MiG-31s, including 349 baseline models, was produced at the Sokol plant between 1976 and 1988. The second batch of 101 MiG-31 DZs was produced from 1989 to 1991. The final batch of 69 MiG-31B aircraft was produced between 1990 and 1994. From the final batch, 50 were retained by the Kazakhstan Air Force after the dissolution of the Soviet Union. Of the baseline models, 40 airframes were upgraded to MiG-31B standard. Some upgrade programs have found their way into the MiG-31 fleet, like the MiG-31BM multi-role version with upgraded avionics, new multimode radar, hands-on throttle and stick, HOTAS controls, liquid crystal LCD, color multi-function displays, MFD's ability to carry the R-77 missile and various Russian air-to-ground missiles, AGMs, such as the Kh-31 anti-radiation missile, ARM. A new and more powerful computer, and digital data links. A project to upgrade the Russian MiG-31 fleet to the MiG-31BM standard began in 2010. 100 aircraft are to be upgraded to MiG-31BM standard by 2020. Russian Federation Defense Ministry Chief Colonel Yuri Balako has claimed that the upgrade will increase the combat effectiveness of the aircraft several times over. 0.18 MiG-31 BMs were delivered in 2014. The Russian military will receive more than 130 upgraded MiG-31 BMs, and the first 24 aircraft have already been delivered, Russian Deputy Defense Minister Yuri Borisov told reporters on the 9th of April 2015. Russia plans to start development of a replacement for the MiG-31 by 2019. The aircraft will be called POC-DP, Prospective Air Complex, for long-range interception. Development of the new aircraft, designated MiG-31, began in April 2013. Such development is favored over restarting MiG-31 production. In March 2014, Russian test pilot Anatoly Kovoshor said that work began on a Mach 4-capable MiG-41 based on the MiG-31. Later reports said that development of the MiG-31 replacement is to begin in 2017, with the first aircraft to be delivered in 2020, and the replacement entering service in 2025. Like the MiG-25, the MiG-31 is a large twin-engine aircraft with side-mounted air intake ramps, a shoulder-mounted wing with an aspect ratio of 2.94, and twin vertical tail fins. Unlike the MiG-25, it has 2 seats, with the rear occupied by a dedicated weapon systems officer. The MiG-31 is limited to 5 grams when traveling at supersonic speeds. While flying under combat weight, its wing loading is marginal and its thrust-to-weight ratio is favorable. The MiG-31 is not designed for close combat or rapid turning. The wings and airframe of the MiG-31 are stronger than those of the MiG-25, permitting supersonic flight at low altitudes. Like the MiG-25, its flight surfaces are built primarily of nickel-steel alloy, enabling the aircraft to tolerate kinetic heating at airspeeds approaching Mach 3. The MiG-31 airframe comprises 49% arc-welded nickel steel, 33% light metal alloy, 16% titanium and 2% composites. Its D30F6 jet engines, each rated at 152 kilonewtons thrust, allow maximum speed of Mach 1.23 at a low altitude. High altitude speed is temperature redlined to Mach 2.83. The thrust-to-drag ratio is sufficient for speeds in excess of Mach 3. But such speeds pose unacceptable hazards to engine and airframe life in routine use. The Su-24 is a supersonic all-weather attack aircraft developed in the Soviet Union. The aircraft has a variable sweep wing, twin engines and a side-by-side seating arrangement for its crew of 2. It was the first of the USSR's aircraft to carry an integrated digital navigation attack system. It remains in service with the Russian Air Force, Syrian Air Force, Ukrainian Air Force, Azerbaijan Air Force, and various air forces to which it was exported. Surviving Su-24M models have gone through a life extension and updating program, with GLONASS, upgraded cockpit with multi-function displays, MFDs, HUD, digital moving map generator, shell helmet-mounted sights, and provision for the latest guided weapons, including R-73, AL-11, Archer, air-to-air missiles. The upgraded aircraft are designated Su-24M2. The Su-24 has a shoulder-mounted variable geometry wing outboard of a relatively small fixed-wing glove, swept at 69 degrees. The wing has 4 sweep settings, 16 degrees for takeoff and landing, 35 degrees and 45 degrees for cruise at different altitudes, and 69 degrees for minimum aspect ratio and wing area in low-level dashes. The variable geometry wing provides excellent STOL performance, allowing a landing speed of 230 km per hour, 140 miles per hour, even lower than the Sukhoi Su-17 despite substantially greater takeoff weight. Its high wing loading provides a stable low-level ride and minimal gust response. The Su-24 has 2 Saturn Leo KL-21F3A afterburning turbojet engines with 109.8 kilonewtons, 24,700 lbf thrust each, fed with air from 2 rectangular side-mounted intakes with splitter plates, boundary layer diverters. In early Su-24, Fencer A, according to NATO aircraft, these intakes had variable ramps. allowing a maximum speed of 2,320 km per hour, 1,440 miles per hour, Mach 2.18, at altitude and a ceiling of 17,500 meters, 57,400 feet. Because the Su-24 is used almost exclusively for low-level missions, the actuators for the variable intakes were deleted to reduce weight and maintenance. This has no effect on low-level performance, but absolute maximum speed and altitude are cut to Mach 1.35 and 11,000 meters, 36,000 feet. The earliest Su-24 had a box-like rear fuselage, which was soon changed in production to a rear exhaust shroud more closely shaped around the engines in order to reduce drag. The revised aircraft also gained 3 side-by-side antenna fairings in the nose, a repositioned braking chute, and a new ram air inlet at the base of the tail fin. The Su-24's fixed armament is a single fast-firing GSH-6-23 cannon with 500 rounds of ammunition, mounted in the fuselage underside. The gun is covered with an eyelid shutter when not in use. The armament includes various nuclear weapons. 2 or 4 R-60, NATO A-8, AFID infrared missiles are usually carried for self-defense by the Su-24M, 24MK. Initial Su-24s had basic electronic countermeasures (ECM) equipment, with many Su-24s limited to the old Serena radar warning receiver with no integral jamming system. Later production Su-24s had more comprehensive radar warning, missile launch warning, and active ECM equipment, with triangular antennas on the sides of the intakes and the tip of the vertical fin. This earned the NATO designation, Fencer C, although again it did not have a separate Soviet designation. Some, Fencer C, and later Su-24M, NATO, Fencer D, had large wing fence pylons on the wing glove portion with integral chaff flare dispensers. Others have such launchers scabbed onto either side of the tail fin.